start recording. All right, so today is the first day for our chapters. Okay. Everything is not in the right place. Hold on, let me put this. He turned off everything. He even turned off keyboard and mouse. I don't know why he did that. Okay, so we're going to talk about the whole numbers. Okay? Does anybody remember anything about the number system? What do we start from when we're talking about number system? What do we start from when we're doing the number system? Let's think about the little kids. Like even kids, before they went to the preschool. Which number system do you think they're gonna start with? What is it?
Zero.
Zero? Do you think they start from zero? Or one? And then two, bless you. 3, 4, da 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 da, right? So they start from, yeah, thank you so much, guys. This is better. Okay, so they start from numbers like 1, 2, 3, 4, why?
They use their fingers when they count.
Right. When they count, right? They can use their fingers or they can just point out the items and say 1, 2, 3, and so on, right? Using the one-on-one correspondence there. So they start from counting numbers. And what do we call the counting numbers? Another fancy name for counting numbers. Starting with an N, natural numbers. Okay? So when we are doing 1, 2, 3, 4, those counting numbers are called natural numbers. So that's what little kids do when they're in preschool. And even in preschool, we're going to introduce one important number there. What is that? Diana, you already talked about it.
Zero.
Yeah, that big fat zero. It's very important in our number system because it's going to be used as placeholder, right? It's very important number. So zero concept will be introduced to the little kids after they learn about the natural numbers. And what do we call the number system? I mean W, the whole number. Yes. So the whole number starts from zero and all the counting numbers. So if we use number line, we can only talk about 0, 1, 2, 3, and so on on this side. So we're not gonna talk about any number that is negative. We're not gonna talk any number between these whole numbers like fraction numbers or decimal numbers. Okay. So what we're gonna do here is we're gonna talk about how we add, subtract, multiply, or divide using these whole numbers. And I'm gonna keep reiterating about the number system, and we're gonna increase the number system up until the real numbers. Okay, so please remember the number system. Right? So okay, so what we're gonna do here in the whole number is addition first. Okay, we already know about the addition, but when we're doing addition, how would you teach your, let's say, first grade or kindergarten students about addition? You're just gonna write the number and put addition sign and solve the problem? I don't think you would, right, Hannah? How would you do it?
closer to.
Yeah, we're gonna use actual items, right? Physical, tangible objects. I think that's a great way, something that are very similar, I mean, that very familiar to them, right? That's a really good way to start with. So we're gonna talk about the relationships, including comparing and ordering, using the tangible objects too. Okay, so these are the topics that, let's say, objectives that we're gonna do for this section. We're gonna see the number relationships that includes which one's bigger, which one's smaller, how can we order them, and we're gonna learn about the meaning of addition using different models. So not only one model that we can use as this set and this set together is the addition. We're gonna have different models too. And we also want to talk about properties of addition and how to use them. And we're gonna talk about addition algorithm. That's a more efficient way. So we're gonna start with the tangible objects first, okay? Okay, and then we're gonna extend our addition knowledge in whole numbers to mental addition and explanation, etc. Okay, so the first addition model on our textbook suggests is the set model. In 137, we talked about sets, right? Now in sets, we talked about elements. So what's the set and what's the element? Anybody remember? Just anything. Like set, we denote that with capital letter, right? So that's actually the title of the whole set. If you think about the Venn diagram, here is a set, one set. In one set, for example, let's put math 235. We have a set named math 235 in Chevron State College. What's the elements in it? Us, right? Each individual, you and me, we are the element in it. And do you remember the symbols and da 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 da? You don't need to teach all that to your elementary school students. That's way too much. But for teachers like you just need to know what the set means and what the elements mean. And if you guys remember, we also talked about this kind of notation. This way. Okay, so let's suppose here is a set A. Is it coming back to you now? You have a lot of elements in it. Let's say A, B, C, D, E are the elements in it. So we have the relationship between the element and the set. How do I denote that A is an element of A? Set A. Right? Yeah, so this means A is an element of A. Capital A, set A. Right? If I have another set B, we can see the relationship between set A and B. A is a subset of set B. It's not relevant, but I just wanna, review those things. So we have those notations, but this one says that small a is an element of set A. Okay? And if you guys remember anything about N of A, what does that mean? What does N of A mean? N means the number of elements in set A. So how many elements are in set A? 5. So you can just say, oh, N of A is 5. Okay? We're going to use that in this classroom. So if you have an addition, let's suppose you have 2 sets. One set, let's say set A and set B. And in set A, so let's have A student has 1, 2, 3 blocks. And this student has 2 blocks. When we are adding them together, we're just gonna put these two together here and put, 1, 2, 3 from student A and 2 blocks from student B, right? If we connect this to the set model, it's gonna be like this. Number of elements in set A, which is 3, plus number of elements in set B is equal to 5, which is number of elements of A union B. Is it coming back to you? Okay, so when we are having number of elements in A union B, we usually do number of elements in A and number of elements in B, and you subtract whatever is in both. So going back to the Venn diagram, A and B, this is a typical model for two sets, and this is intersecting part, isn't it? Because this is counted in A and B, you need to take away that is double counted. That's what it is, right? However, in this case, there's nothing overlapping. This block is only in A, and this block is only in B. There's nothing in the overlapping part. That's why this is 0, and we have only number of elements in A and number of elements in B is the union of A and B. Does it make sense? And what do we call when there's nothing overlapping? We call these sets as disjoint. There's nothing in joint, okay? So it's called a disjoint set. So a lot of cases for younger students, their sets are all disjoint. So they can just count this number of items in this part and the other part, they can just add them together. That's an addition in set model. Kind of complicating because I talked about the denotation and the elements, But basically, what we are doing with our students is, well, we're gonna add these two groups together. But what we are doing is we are counting what's in it. Right? We're just gonna add them together and get the total number. Okay, that's the same model. So when you are solving some problems in the MyMathLab, it's gonna ask you some notations like that. So number of elements in A plus number of elements in B is, in this case, because they're disjoint, number of elements in A union B. Okay? So know that you can solve some problems like, like this. So suppose Jane has 4 blocks in one pile and 3 in another. If she combines the two groups, how many blocks are there in the combined groups? Very simple problems, but if you connect this to the set model, you can see that, oh, one pile is one set, the other pile is another set, and there's nothing disjointing. Nothing jointing, right? Nothing overlapping. So it is a set model that you can use. So you can just add those two together. I just wanna introduce you some virtual manipulatives here. So these are just like counters that we can use with the tangible models. If you are not in situation of a pandemic, you can of course give your students the counters like this and say that, oh, I have 4 red counters and my friend Lindsay have 3 yellow counters. How many counters are there together? You can just count, by putting them together, because it's the total number. Okay? So set A has 4, set B has 3. Together, there are 4, 5, 6, 7. But we're gonna also talk about counting method. There are a lot of different ways of counting. Some students can subitize. Does anybody remember about subitizing? Subitizing is you just see that and know right away. Like dice. If you see the dots, you can get to know what the number is without counting them, right? So like this one, I see that, oh, that's 7 without counting 1, 2, 3, 4, 5, 6, 7. That's called subitizing. Okay, you're gonna learn that in math class. Anyways, that's one way. Another way you can go like counting on. So we know that there are 4. Then count on from there. 4, 5, 6, 7. Right? So there are a lot of ways of counting, or you can do double it. So I see 3 and 3, that makes 6, and there's one more, so 7, things like that. Okay, you can always connect a lot of different, mathematical topics within your topic that you are doing now. Okay, so let's take a look at this definition of addition of whole numbers. Does it make sense? So it says number of elements in set A is small a, and number of elements in set B is small b, then A plus B is number of elements in A union B, because there's nothing overlapping, okay, in the small section. Okay, so that makes sense to us. We can also use number line model. We heavily use number line models, right? Especially for real numbers. So when we extend our number to the real number, we're gonna use the number line heavily, because all the numbers on the number lines is real number. So what are we doing here? Only the whole numbers. So only those tick marks, 0, 1, 2, 3, is what we're gonna work on. So keep that in mind. So here is number line models. So we can start from 0 because we're working on whole numbers. Let's put something like 20. So like this. So we're gonna work on only these tick mark numbers, okay? If I add 4 and 5 together, how do I start from? Where do I start from? Which number do I start from? You need to start from 0, right? Starting from 0, you can go all the way to the, let's say 5 plus 1, 5. Right? Okay, from 0, you can go to 5. So I jumped onto 5. Okay, then I can add 4 more. So you go 1, 2, 3, 4, plus 4. And where you land, that is the sum. That's the answer for this addition, 5 plus 4, isn't it? Guess the most mistake that students can make. How could that be?
They start at 1 instead of 0.
Yeah, that's the common mistake, surprisingly. Instead of starting 0, they go from 1 and go to 5. Or they start from 1 and jump 1, 2, 3, 4, 5. That's a common mistake. Another common mistake they can do is, instead of counting the skips, how many jumps they have, 1, 2, 3, 4, 5. So we actually counted how many spaces we jump, right? So sometimes they count like 1, 2, 3, 4, 5, and then jump 4. That's another mistake they can have. So whenever you notify that from your student, please make them correction, okay? Okay. So that's how you use the number line. There. Okay. So make sure you start from 0, and you're gonna count the spaces that you are hopping to. So 1, 2, 3, 4 plus 1, 2, 3 is 4 plus 3. And the answer is where you land at the end, right? It's too easy for you, so it's kind of boring, isn't it? I understand that. But, because you need to teach this, we just want to review all that. Okay, and once they know how to use those models, we can also think about basic addition facts. You can always do, some fun games with your students about addition facts. And I already talked some about these, strategies of counting or adding, I mean. So one is counting on. So if we are doing 5 plus 3, we already know that 5 is there. So count on from 5. You just need to add 3 more to it, right? So 5, 6, 7, 8. You can always use your fingers. I see a lot of students, my college students are doing that too, and I do that too. So what's wrong with that? That's easy to do. And doubles, you already know doubles are fact. Then you can just use that doubles. Like we already know 2 and 2 makes 4. Then when you're doing 3 and 2, 3 plus 2, you can do 2, 2, and there's one more, right? So you can always use that. Making 10 is another good strategy, and we do this heavily, right? Because whenever you have 10, that's so much easier for us to look at. Have you guys ever seen a 10 frame tile? Probably not. How about rack and rack? Probably not, right? So this is a frame, 10 frame. It's gonna be in one of your reading assignment too. I think the first reading assignment is talking about 10 frame tile. This is very useful. Why? Because our number system is base 10. We have 10 fingers, right? So it was so much easier for them to recognize if the whole frame is filled, that's 10. If 2 are missing, that's 8, right? So 10 frame tile is very, very useful to use making 10 strategy, especially. So when we are doing 8 plus 6, for example, we can build up this 10 frame tile with 8 counters, and you just need to build up 6 more to it. In order to do that, you're gonna break 6 into 1 and 1. How many more do you need? You just need 2 more. So you can make 6 into 2 and 4. So build up 2 there, then that's 10, and you have 4 out there. So the total number is 10 and 4, 14. Okay? So that's so much easier for them too. Okay. And let's talk about some properties. Closure property is the first thing we're going to talk about. Can you guess what closure property is? Come on, don't be shy. Closure property. Okay, closure property is it's closed. So we are working on the whole number, right? So whenever you are picking any number that is a whole number, now we know this denotation, right? A is an element in the whole number set. So any whole number and another whole number, right? And you are adding them together, that's also a whole number. That is a closure. So picking any 2 whole numbers, any 2 or 3 or 4 whole numbers, adding them together, the sum is still a whole number. That is called a closure. Okay? What other property can you think about when we're talking about addition? So that's the first thing. If it is a closed, if the closure property works, we can think about other properties too. Any property can you think about? Come on.
The commutative.
What is it?
The commutative.
The commutative property. Awesome. Commutative property. What does commute mean? I commute. What does that mean? That means I'm not on campus, right? I come from my home to school and, So commutative property means you can switch things around. Okay, so A is still in whole number and B is still whole number. When you add these together in this order, it's same as moving them around, B and A. So 2 plus 3, for example, is the same as 3 plus 2. So if you switch things around, commute the numbers around, it's still the same. The equality still works. Okay, that is called the commutative property of addition, because we're working on the addition, okay, in whole numbers. What other property can you think about? Come on, what is it? They are not-
Associative.
Associative, thank you. Associative. So, when we're talking about associative, what does that mean? You're social, you're associating with somebody.
And grouping.
Yeah, you're gonna group together, right? So for example, if I write A plus B plus C, what do we do first? We add A and B first, right? We add these two together. So this is the same as you have a parenthesis there. Okay, so I'm gonna put the parenthesis. This is the same as, without changing the order, I'm still adding A plus B plus C, but I'm gonna associate B and C first. Remember in the order of operation, we do parentheses first, pandas, P, parentheses first, right? So that's exactly same equality. For example, if I do 2 plus 3 plus C, let's put 4. Let's see if they are equal. That's same as 2 plus 3 plus 4. Let's examine that. What's 2 plus 3? 5. Plus 4? 9. So on the left hand side, I have 9. How about on the right hand side? So I'm gonna do 2 plus, I'm gonna do 3 plus 4 first. What's 3 plus 4? 7. 2 plus 7? 9. If you compare the middle part here, they are not the same. How about the product? I mean the sum, the final answer is the same, right? So even if I start from adding these two first, that is exactly the same as I add the other two by associating them first. Okay, that's called associative property. Okay? And here, very, very important thing I need to mention is equal sign. It's very important because I see the mistakes of our pre-service teachers so many times, even in-person teachers, in-service teachers are making this mistake. The common mistake they do is like 2 plus 3 plus 4 is equal to 5. I mean, when they're doing this, they do like 2 plus 3 is equal to 5 plus 4 is equal to 9. You saw this a lot of times too, right? So is this right way to use equal sign? It's not. Why not? Because they are not equal. Look, 2 plus 3 is 5. But here, 5 plus 4 is 9. They are not equal. You cannot put equal there, right? So it's equal to run on. You shouldn't run on with equal sign. If you want to write 2 plus 3 first, you can just say that is equal to 5. And then in the next line, you can put 5 plus 4 is equal to 9. There's no problem. Or you can do 2 plus 3 is equal to 5, and then you can add 2, 4, and that's 9. This is okay, and this is okay, but this is not okay. Big no, 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 okay? So be careful when you are writing the equal sign. Any student from me shouldn't do this one, okay? So be very, very careful about that. Okay. Oh, we have one more property. That is called identity property. What is identity? What's your identity? What's your identity, guys? Anybody? Gentle, if I ask you what's your identity, what would you say? But what do you want to talk about then? You want to talk about me? When I ask you your identity?
I don't know what I'd say.
See, she's gonna talk about herself, right? So thank you. So identity about yourself. So if we bring that to the math here, it's like this: 2 plus something is 2. 2 becomes 2. You get yourself, right? That's identity. What do I add? 0. Big fat 0. or 0 plus 2 is 2. So whenever you add some number, any whole number by 0, you get yourself. That's called the identity property. Okay? So in general, we can say A plus A again is a whole number, plus 0 is equal to 0 plus A. That is A. That's an identity. Very good? Okay. All right, so that's about the property, and we know all about this now, right? We can always apply this to the problem here. Okay, so take a look at this problem. 18 plus 7 plus 2. How would you solve this problem easily? How would you solve this problem easily?
18 plus 2. Solve that first and then add
Okay.
7.
So what you did is, Diana just said 18 plus 2 plus 7 instead of doing 18 plus 7 plus 2, right? So starting from 18 plus 7 plus 2, are they still equal? They are. What property did she use? What had happened? These two have switched, right?
Yeah.
Reagan, what is it? Community property. Excellent. And then what can we do? We can just add these two together. Is that associate property? Yeah, not really.
That's kind of what
because-
I meant for it to be, like, to do 18 plus 2 first, and then you add this.
Yeah, but since we already have 18 plus 2 at the beginning, we didn't do anything, right? We just add those two together. So 20 plus 7 is 27. Just simple addition. Okay? So we use the community property. Excellent. Let's look at the next one. How about this one? What property would you use, or how would you add these two together, these three numbers together? Anyone?
I would group 7 and 13 first to make 20.
Oh, instead of adding these two first, you're gonna add these two first. So that's same as 18 plus 7 plus 13, right? So we regrouped, we changed the association there, right? It's called associative property. So we're gonna do 18 plus 20. What's 18 plus 20? 38. Nailed it. Awesome. How about the next one? Okay. Using base 10 blocks to develop the standard algorithm. Okay. So we are done with all the inventive and all the properties and stuff. Now we can do the standard algorithm. Okay, after doing all that stuff. Okay, what do you know about the standard algorithm? Well, we add from the ones place, then if there needs any regrouping, we're gonna regroup that into the next visit, da 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 da. That's the algorithm, isn't it? But if you give students like this problem, for example, what would be 14 plus 23? Do you think they would do from the ones place or from the tens place? For example, I'm giving you, let's suppose you guys have $14. Okay? So you have $14 in your hand and I'm giving you $23. How would you count that? Well, without counting, how would you add them together? You have $14, I gave you 23. How would you count them? Me too. That's what little kids do too. So we're gonna talk about that in mental math as well. Usually they start from bigger digits. The first digit that comes on the left hand side. Like we have $200, $243 plus $107. I would go with $100 bills first. That's so much easier, right? So when you're doing mental math, we do that. Unlike that, we're gonna use, we're gonna start start from ones digit when we're doing standard algorithm? Why do we do that? Because I think it's kind of against our thinking process, isn't it? Why do we do that though? Have you ever thought about that? Let's ponder about it. Why do you think we start from the ones place?
In case you have to carry over to the next one.
That's really good point. When we are adding some numbers like ones digits, it can be two digits, like a plus 6, it's 14. It doesn't fit in only in one place, right? So we can carry that over. So we're gonna have some regrouping there. If we go from the tens digit, it's hard to regroup, right? We can't. For subtraction, yes, we can. But for addition, we need to start from the ones place, and if they need any regrouping, we're gonna do the carry over to the tens digit, right? That's why we're doing that. So we love to use our Pandora object, and base 10 blocks is very, very useful because our number system is base 10, right? So here are some base 10 blocks. You just give me any number. Let's start with a small number. What plus what do you want to do? Pick any number. Hurry up.
11.
11. So we need to have one rod, one pen, and 1. That's 11. Plus what? 17. So 10 and 7 of these. 1, 2, 3, 4, 5, 6, 7. Right? And we can say this is called 11. And even if I wrote 1 and 1 here, this is tens place, so it's 10, 1, 10, and that's 1, 1. And we write this as 10, 1, 10, and 7. Right? And when we are adding them together, we can count them all together. So starting from ones place, how many ones are there? There's 7 and 1 more. That's 8. And then go to tens place. How many tens are there? 2 tens, right? If we have to, well, let's have some situation of removing. So instead of that, it doesn't work. 1. Here. Come on. Why is not 3? I don't want to restart it. What can we have to? Okay, if we have to. So if we have to do something like 1, 2, 1, 2, 3, 4, 5, 6. So 10 and 16 plus 20. Let's do 5. 3, 4, 5. So this is 110. And what is it? 6? We call that 16. How about this? This is 210. This is 25, right? If we are adding these two together, what do we do? How do we add these two together? Well, we can see that these 5 and that 5 together makes 10 ones, right? 10 ones is the same as 1 rod. So what do? We regroup or trade it with 1 rod. So I can write small ones here. I added 1 more rod there. Okay? So what I can do here is now I have 1 left here. That's 1. And I already had 1 rod and another 2 rods, but I added 1 more. So I'm gonna count all of these rods together. How many rods are there? 4 rods. So you can connect this integral model with carry over and regrouping there, right? Okay. So that's pretty much what we are doing here. Okay. So we can do that. We're not gonna have to do this again, right? Because we must cover that. Okay, so addition algorithm. Can you use base 10 blocks to solve this one? Yes, we can use regrouping there. I'm not gonna go heavily onto this because you guys already know that, right? So we start from adding ones, and then we're gonna add tens. This is called expanded algorithm. As you can see, the difference between standard algorithm that I showed you with the carry over, this one shows 7 plus 8 is 15, right? And this 3 is not 3, it's a 30. 3 tens is 30. 30 plus 20 is 50. So you're gonna add ones first, then add the tens first. What you need to be careful with your students is, this is not 3 plus 2. That's 3 tens plus 2 tens. Be precise about that, okay? So your students don't get confused about the numbers. 3 tens plus 2 tens is 5 tens. 5 tens is 50. You're gonna write 50. That's why you put 0 there, right? And then you can just add them together. That's expanded algorithm. And this is a standard algorithm. We can skip these 2 steps. We can just add 7 and 8 together. It's 15. In 15, that 1 is the tens place. So you can put a small 1 above it. Okay? We're gonna talk about that small number above the actual number, because in the subtraction, it has a different meaning to it. But we're gonna put this 1, because it's 110 right above 3, because it's in the same digit of tens. Okay? So you need to line that up. Okay? So can you use both concrete model and standard algorithm to solve 186 plus 127? Yes, you can, right? So on your notebook, you can draw the base 10 blocks. To represent 100, you can use a flat 10 by 10, right? So use that and draw the concrete model of 186 plus 127 on your notebook. And right beside it, use standard algorithm to solve it. Just like I did in, using my manipulatives. It's gonna be similar to this one. So you can try to do that. I'm gonna compare your work with what I have here. Hundred 86 plus 127. I want you to show all the regrouping using the arrows or whatever on your notebook, okay? Hundred 86 plus 127. So I can draw, manipulatives like this. 100, this shows 100, right? And I have 8 rods, that represents 80. and I have 6 units there. And I have 120 and 7. 1, 2, 3, 4, 5, 6, 7. Okay, let's add them together. So when we are adding them together, we can just count them, but there should be some regrouping going on there. So we need to consider that. How can I regroup things? Well, I have 7 here, so if I take only 3, this is just one way. You don't have to have exactly same representation, okay? What I'm gonna do here is I'm gonna regroup these 10 ones, okay? Crossing them out, and I'm gonna carry over 1 here. That's what I carried over. Okay, so now I have 9, 10, 11. So I need to have regrouping here again, right? These are more things. And then cross out, and I'm going to regroup these 10 rods or 10 tens into another black there. So I count. I have 3 100s, and I have 1 10 left, right? And I have 3 ones left. So it's gonna be 313. Is that what you got? Okay, if I use a standard algorithm, we can do the same thing. 6 plus 7 is 13. 13, and that 110. I mean, the 10 ones became 110. So I'm gonna put 110 here, and I have 3. That is 13. And I can add all of these 10s together, 10 and 1, that's 11. And I have another 100 that I regrouped with the 10 tens, right? So I have 313. You got that? If I use expanded algorithm, how can I do that? I can add all of these ones together first. 6 plus 7, 13, 80 and 20, which is how many tens? 80 and 20. 10, 10, which is 100. And I have 100 and 100, 200. So if I add them together, I have 313. So partial sum, this is called the partial sum. Okay, these are partial sum. Or expanded algorithm. Okay, so you need to know all of these differences. And you need to know how to do all of that. Any questions so far? Yeah, good. Okay, we have a couple more minutes, but I got this from your homework examples. Let's have just one more practice for this, okay? Can you give reasons for each of the following steps? Let's look at the first step for 143 plus 22 is equal to 1 times 10 squared plus 4 times 10 plus 4. So 143 is 1 times 10 squared. That shows 1 means hundreds. 4 is not just 4, it's 40, right? So 4 times 10, and 3 is 3 times 1 or 3. And that 2, the first 2 is 20, so it's 2 times 10, and 2 is 2. So what property do you think is used? It just shows what place value they are, right? So what could that be? This place value. Okay? There's nothing addition going on there yet. It just showed 1 is 100, 4 is 40, 3 is 3, 2 is 20, that 2 is 2, showing just place value. From there, what happened? What change do you see? 1 times 10 squared is still there, 4 times 10 is here. Hey, 2 times 10 came here instead of 3. So what happened? What is it?
They regrouped it.
They regrouped it. Not only that, what happened? But also, they switched these two around. Do you see that? Yeah, 3 went behind, after 2 times 10, right? So there was a communal property also going on. But instead of just doing the communal property, it happened with social property as well. And from there to there, what happened? This is still the same. And now what do you see? 4 times 10 plus 2 times 10 become 4 plus 2 times 10. Because I see, oh, times 10 is here and times 10 is also here. You can factor that out. If you go backwards, starting from here, you can distribute 10 to 4, 10 to 2. So going backwards or forward, both are forward distributable property. Right, over addition to the space. And then what happened? 1 times 10 squared is still the same. You just did a arithmetic there. 4 plus 3 is 6. 6 times 10. So that's just what? Single digit addition factor, right? 3 plus 2. Single digit addition. Okay, I think that's it. And let's see. Well, here are some more examples, but I'm pretty sure you can solve the homework problems. If you have any question when you're doing the homework problems, please let me know. Okay? So that homework is